Hey, what's up, folks? This is Ton, and I was just kicking the tires on the Google's Collab notebook last night, and it occurred to me that this might be a fun place to kick around some ideas about what a neural network could learn. So I decided to create some notebooks, and I'm going to share them. And in each one, I'm going to ask a little simple question. In this case, it's going to be whether a neural network can learn to count the number of circles in an image. And the question is, given a really simple network and in a short amount of time, will it learn? Will it learn to do to predict the outputs given the inputs? So I'll include a link in the description to this Collab notebook. You just click on it, and then you'll come to a page that will look something like this. So let's just dive right in. So let's get some details on the first experiment. This is going to be a vanilla convolutional neural network. By that I mean no special bells and whistles. We're going to have as input up an image with up to 1 to 10 circles. It'll be in a black background, and it will be white with a red circle. But we can look at the sample image. So if this is your first time in a Collab notebook, you can see there's kind of a text area here, and then underneath, this is a code cell area. When I can click on this, and then I can click on this little arrow here, and that will run the cell, and it's running, and when it finishes, voila, you'll see there's the output. So this is an example of what the images will look like. If we click it again, you can see that it generates a random set of circles. So this cell will validate whether you're running on a GPU, and it looks like we are, which is really nice because this is free. And let's look at what our network will be. It will be a pretty straightforward 4 layers, 4 convolutional layers, 3x3 filters, 64 each, and then a dense layer of 100 neurons, and then a final output, and this final output will be our count. We'll use mean squared error as a loss, and for our generator, this is actually pretty simple. Normally this would be loading your data, but because we're generating it all, we're just going to call this image with circles that we saw above to yield sets of data to train on. And then we'll click on this and we'll start training right in the browser. So what this is actually doing, it's connecting to a virtual environment in Google's cloud, and it's got a GPU, so it's running through 256 times 64 images per epoch, and it's finishing them in about 12 seconds, which is really nice. So within a minute, this will train. You will train to a certain level of accuracy. You can see that the accuracy is increasing here slowly. Actually, not that slowly. It's per epoch, it's doing nicely. It has some issue with the image drawing, refreshing in this window. Occasionally it does well, occasionally not. So we know it will do better with a larger data set and longer periods of time if it can learn it at all. And that's kind of the idea behind this, is to test your intuition. It's clear that a convolutional neural network can classify images. It could certainly tell you that it was looking at a square versus a circle versus a triangle. But within that image, can it count the number of instances? And this is somewhat interesting given the tweet from this afternoon from DeepMind about their neural arithmetic accumulation unit. You can search on Twitter and you can see that, or maybe I can put a link in there. So they seem to indicate that with this additional information that it will do better at counting. And actually last night it just happened to be a coincidence that I chose this as my problem, my first problem. So it overlaps that. Okay, so now it finished training, and it says the final accuracy was something around 60%. So let's see, what does that mean in real life? So we'll generate a new circle set, we'll run prediction on it, and then we'll see the output. Okay, so this first output generated 7 circles, so this is our ground truth, and there's 1, 2, 3, 4, 5, 6. I don't see the 7th circle, so it could be overlapped by one of the other ones. For some reason, this is also producing a prediction of 7 circles, which is kind of creepy that it's that good. This says it produced 3 circles, so 1 was overlapped, and this is counting 2 circles, which is more like I would count. This is saying 8 circles, 1, 2, 3, 4, 5, 6, 7, 8, and this is predicting 8. So far it's actually not half bad. Okay, this one is predicting 9, and there were 10. Again, there might have been overlap. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No overlap. This should have hit 10. It was definitely deficient there, but only off by 1. 1, 2, 3, 4, 5 circles. This is predicting 6. This looks correct. 9 circles. Quite a lot of overlap. 5 circles. This one is off by 1. This one is correct. This one is off by 1, but it's clearly overlapped. There's 1, 2, 3, 4, and there's 1, 2, 3, 4. So you can do this for yourself and kind of see what you get. When I ran it, I was a little surprised actually how good it was. I did not expect it to do this well at all. I'm kind of curious what you guys think, if you guys totally predicted that this is going to happen, or if it's, as it was for me, somewhat of a surprise. And I'm kind of curious, would this scale to the real world? You know, what happens if we were given a conveyor belt full of objects? Would it be able to count those objects as it went by in the real world? Or, you know, what kind of challenges would a real image data set produce? So I hope that was interesting, and go ahead and let me know if you have any ideas for other episodes. Thanks.